Yeah, leaning towards a yes or a no on this one? Let's see. Well, do we have the fixed number of trials? Something we could use for n? 36% would fit in somewhere. 10 would fit in somewhere. Looks like n could be 10, doesn't it? Fixed number of trials. Each one's independent because we're asking different people. Probability of success would remain the same. 2 possible outcomes. Looks like a yes. Besides, if we said no, we wouldn't have any more to do, would we? Probably going to be a yes. What about that 36%? Do you see where it fits in? It's the P. Yeah, we could turn it into a decimal, kind of like our 80% over here. We said we could use as 0.8, 36%. So each time we survey and ask someone, the chance that they say yes was 0.36. So that's all kind of based on what we've talked about so far. This is a little bit different. Anything we want to double check up to that point? So what do you suppose is considered a success in this case? If someone says yes, they play on their phone. That's right. Out of the 10 that we're talking to, how many could say yes, I play on my phone? Could all 10 of them say yes? Super likely, since this is kind of a low number, but it's possible. Could 9 of the 10 say yes? Yeah, or 8 or 7 or 6, all the way down to, could 1 of the 10 say yes? Could none of the 10 say yes? So X could be anything from 0 up to 10. If we're talking to 10 people, anywhere from 0 to all 10 of them could say yes, could be a success in our experiment. In general, X can be anything from 0 up to X itself. X was 5. I'm sorry, again was 5. I meant to put in there, didn't I? Let's try again. In general, X can be anything from 0 up to n. It could be the complete full number or anything up to that, starting with 0. And now that kind of starts to get at what sort of probabilities we'll be asked to find. They're going to ask us things like, find the probability that 7 out of the 10 say yes, they play games on their smartphone. The question could be anything, 0 to 10. I just happened to pick out 7. We've already seen that it's kind of a low percentage of folks here, 36%. So finding 7 people that say yes is probably going to be even lower. You could calculate that probability with a little formula here. Let me explain a little bit how it works. First off, if we're finding the probability that 7 say yes, we might see it written P of 7 or probability P of X equaling 7. That's the sort of labeling we might see on these questions. And then since we're talking about 7 out of 10, we would involve a combination. We'd need to know how many ways you can even pick 7 out of 10. And if we're expecting or thinking about all 7 of those people saying yes, that would involve our multiplication rule. The first one says yes, and the second one, and the third one. So we're going to multiply all those 0.36s together. And also, then the other 3 would be saying no. If we have a 36% chance of someone saying yes, falling in this category, what's the percent that don't? Yeah, so the other 64%. And that's what the Q up here stands for. P's the probability of success, Q's the probability of failure. We don't tend to need the Q a lot because we rely on our calculator, but once in a while it shows up. So probability of failure. We're thinking about 7 people saying yes and the other 3 saying no. And that's basically where the formula comes from, how it's constructed. But good news I expect is that the calculator knows this formula and we can really rely on the calculator to find that answer with a few buttons that we'll punch over on the next page. We'll press the second button and then the variables button and look for the binomial command. So second variables binom, it's right there at the top of the next page. Then it'll ask us for some of the numbers like the N and the P and the X. And we'll get the answer. Same answer we would have gotten if we crunched the numbers in that formula. So we said second and then variables. The vars key is just right below the arrows here, VARS. On some calculators like this one, it's option 0. So it goes 1 through 9 and then 0. On other calculators like this one, it's actually option A. So second vars, 1 through 9, 0, A. So it depends on your calculator. Could be 0 or could be A. What we want it to say is binom PDF. Probably the very first binomial command you see. So we'll find it, we'll press enter. If your calculator is like the one on the right, it'll prompt you, ask you how many trials there are. That's the N number. N was 10 here. And it'll ask you for P, the probability of success, like 0.36. And then it'll ask which X you're interested in, and we picked 7. Then you can hit enter a couple of times to bring that back to your home screen and get your answer. If your calculator is like the one on the left, you're going to put those same 3 numbers in the parentheses with commas between them. So it just depends. What do you guys have out there? Are you more like the one on the left or the right? Yeah. Did it work out okay?
I guess.
Being the probability is a good chance we'd be asked to round it to 3 digits, like 0.025. And again, that's the exact same thing we would have gotten if we use our combinations and probability formulas from chapter 3. If it's going okay, then you can try the one below. Same calculator command. If you need any help with the first one, let me know. I think it was some button or something.
Yeah, just depends on.
Okay. Good deal. Yeah. Uh-huh. Yeah. So maybe we're already on a different screen. Let's try again. Second bars. Yeah, that's good. Yeah.
Okay, $7 and $170. So, well, let's go down and see. There you go. There you go.
They mentioned 40%. Is that gonna be one of the numbers we need? Which one does that help us with? That's the P, yeah, 0.4 or 0.40. And 11, where's the 11 fit in? Yeah, we could find Q, but we're not gonna need it, says the calculator knows. But if we were asked about it, that'd be 0.6 or 60. And what about the X? That's gonna be the 5 that they're asking us about. That's right. So probability of 5 with our binom PDF. We'll put in the 11 and the 0.4 and the 5. And let's say we rounded it to 3 decimal places. What are you getting? That sounds great. 0.221, 11.45. Here, 11.45. 0.221.